Hi, so for today we are going to talk about dot and cross products, okay, in electromagnetics, and I'm going to have two examples here in our given topic, dot and cross products. Again, this is a part of the electromagnetic playlist. Okay, I'll be continuing the electromagnetics playlist for the upcoming videos. So let's get started. So for number one, given the points A, quantity 2, 5, negative 1, we have the point B, 3, negative 2, 4, and C, we have negative 2, 3, and 1. Find first, letter A, the dot product of the vector R AB and the vector R AC. So the important thing that we should remember when we are computing that product always results to a scalar quantity. So it's a number. Okay, it doesn't have any unit vectors in it. Okay, so it's just a magnitude, a scalar quantity. Whereas for cross products, okay, the result of a cross product, if we get the cross product of the two vectors, the result is a vector. Again, it is clear. If we are getting the dot product of a two vector, that results to a scalar quantity. But for a cross product, it results to a what? Vector. Okay, so first, what are we going to do here is first we should get the vectors RAB and RAC first. Okay, so we know that the terminal here is point B, so we will be starting with point B. So we have 3 for B, okay, for our B here, minus what? The point A, okay, and that would be AX, okay. Then plus, we have negative 2 minus 5 AY plus we have 1 minus negative 1. Okay? So 1 because of 1 here minus negative 1 here. And that is in terms of A sub A. So we need first to get the, what do you call this? Oops, of course, this should not be 1 negative 1. Okay, so let me just rewrite this. This is a correction. So we have for our AB, that should be what? 4 minus negative 1. Here is the 4. Okay, my mistake for writing 1. Okay, so what I saw is this instead of this one. So, upon evaluating, we have 3 minus 2, that's AX. Okay, minus 7 A sub Y. And then we have plus 5 A sub C. So that's the vector RAB. How about for the vector RAC? The terminal point is AC, so we'll start with C. So we have what? Negative 2 minus 2. That's for our AX. Then we have 3 minus 5. That's for our AY. And then we have plus 1 minus negative 1. 1 minus negative 1 A sub Z. So we have negative 4 AX minus 2AY because of 3 minus 5 here. 1 minus negative 1 would become plus 2A sub Z. So when we get the vectors RAB and RAC, we can find the dot product, okay, if it is in terms of the IJK or unit vector or AX, AY, AZ, we can simply get the dot product RAB dotted by the RAC by simply getting the sum of the products of each vector. Okay? So we have here for RAB, we have a constant coefficient of 1 for AX. Okay? And then we have negative 4 for RAC. Okay, that's the product. And then we're going to add it. Okay, this is the sum of the products with the AY. So including the sign for RAB, we have negative 7 and we have negative 2 here. So we have negative 2 and then plus for A sub Z, for the Z, so we have plus 5 times 2. Okay? So upon evaluating, we have negative 4 plus 14, okay, plus 10, okay, that's equal to 20. So the resulting dot product of the RAB and RAC is 20. Okay. So letter B. Okay, so this is letter A of number 1. Letter B, the angle between the vectors RAB and RAC. So if we may wish to recall in our study of vectors, if we are getting the dot product of two vectors, we know that A dotted by B equals the magnitude of A multiplied by the magnitude of vector B, and then what? Cosine of theta, where theta is the angle between between the vectors A and B. So the same rule we will be applying. Since we have RAB, we have vector RAB, then we have vector RAC. Okay? So we can get the magnitude of vector RAB, and then magnitude of the vector RAC, and then we have cosine theta. Okay? So isolating theta, okay? So what are we going to do? We have cosine theta here. So we have dot product of RAB, RAC, of which that is equivalent to 20, okay? All over the magnitude of RAB, and then magnitude multiplied by the magnitude of RAC. So what are we going to do? What we need is only the theta. So we can further what? Get it by having arc cosine of the dot product of RAB dotted by RAC, okay, all over the magnitude of RAB and then the magnitude of RAC. So first, what are we going to do is to get first the magnitude of RAB. Okay? So we get the magnitude of RAB. So if we get the magnitude, then the resulting is a scalar quantity. So we have 1 squared for this. Okay? And then plus negative 7 squared. That's how we get the magnitude. And then plus, we have 5 squared. That's the formula, okay, for the magnitude. So upon getting the magnitude of the RAB, we have 5 square root of 3. You can also express this in decimals if you want. Okay, so we have to get the magnitude for RAC, the length of the vector RAC. So here we are, we have negative 4. We have to get the square root of the negative 4 squared plus we have negative 2 squared, and then we have plus 2 squared. So getting that, we have 2 square root of 6. And now, substituting to the formula, to get the angle, so we have arc cosine of the dot product of RAB and RAC, which is 20. We have computed a while ago, so we have 20 all over the product of the magnitude of RAB and RAC, of which we have 5 square root of 3, and then we have 2 square root of 6. So, what's the answer? If we calculate it with 2 decimals, 61.87 degrees. So this should be our final answer for letter B. That's the angle between the two vectors. Okay, so we can get it on using the dot product. So the length of the projection of RAB on RAC. So in other words, letter C is asking us for the scalar projection of RAB to RAC. So to get that, the scalar projection, so the scalar projection is the length, okay, of the projection. When we say length, that is a specific number. The result should be what? The result should be a scalar quantity because of the length. So to get the scalar projection of RAB to RAC, we have the formula RAB dotted by RAC all over, we have the magnitude of RAC. So we know that we have the dot product of this. So that's 20, okay? All over, we have the magnitude of RAC, that's 2 square root of 6. So, simplifying, we have 4.08 in 2 decimals. So, that's the length of the projection of RAB onto RAC. Okay? So, if we wish to get the scalar projection of RAC onto RAB, we need to change the formula of the denominator as RAB. Okay? So, letter D. Okay? We can also, I forgot, we can also get the scalar projection using the formula we have magnitude of RAB cosine theta, where theta is the angle between the two vectors. So in that case, we have the magnitude of RAB, we have 5 square root of 3, and then we have cosine of theta, of which the value that we get a while ago is 61.87. So upon evaluating, you should get the same answer. So that's how we get the scalar projection of RAB to RAC. Okay? So for letter D, for this first problem, the vector projection. So the answer here in the vector projection must be a vector quantity. Vector projection of RAB on RAC. So we can simply get the vector projection of RAB onto RAC, okay, by using the formula RAB dotted by RAC all over RAC, K squared, multiplied by what? We have RAC, the vector RAC. Okay? So in this case, we can separate this. Okay, this is the vector projection. Okay? Vector projection of projection, okay, of RAB to RAC. Okay? So what are we going to do here? Since we know this already, okay, so we can rewrite this formula here as we have RAB, dot product of RAB and RAC all over the magnitude of RAC multiplied by RAC all over the magnitude of RAC. Because the square here only signifies the two magnitudes are being multiplied. So we already know this. And this is what we solve on letter C. So technically, the formula, this is not a dot product, this is multiply. Okay? This is not a dot product because this is already the dot product, this one. This one, this one. Okay, this is multiplication. So we have RAB dotted by RAC all over. The magnitude of RAC is this. So we have 4.08. Okay, then multiplied by the vector RAC. What is the vector RAC? The vector RAC here, not this because this is the magnitude. The vector RAC is this. Negative 4AX minus 2AY plus 2AZ. Negative 4AX minus 2ay plus 2az, okay, all over, okay, the 2 square root of 6. Okay, so how you calculate that with your calculator is that, okay, we can have 4.08 divided by 2 square root of 6 and then multiplied distributive by this vector. Okay, so if we do that, first of all, we multiply this one, okay, to negative 4. That would be the value of the x direction. So in this case, that would be negative 3.33 a sub x. Again, how did we get that? We have 4.08 divided by 2 square root of 6 multiplied by the negative 4. And that's the component for the x component. Okay? And then next one is multiply it by negative 2. So that becomes negative 1.667 a sub y. And lastly, we multiply it by 2. Okay, that is obviously plus, okay, 1.667 a sub z. So this is the vector projection of RAB onto RAC. Okay? So this is a resulting vector, while when we get scalar projection, we should get a magnitude or length. Okay? So that's how we perform the dot product. So let's go now to number 2. So for number 2, let me just copy the problem. A triangle is defined by the 3 points A, 2, negative 5, and 1, B, negative 3, and 4, and C, 0, 3, 1. Find the cross product of RBC and RBA. Okay? So first, we need to get RBC, the vector RBC, because this is still a points. Okay? Points. This is still points. So we need to get the vector RBC as well as the vector RBA. So how do we do that again? the terminal here, point here is C. So we start from C. So we have 0 minus 2 AX. So that is 0 minus, I'm wrong again. Okay? It should be BC. So please forgive me. So we have what? RBC. So we have 0 minus negative 3. So we have 0 minus negative 3. That is for the AX direction, X direction. Okay? And the next one, that should be 3 minus 2 for AY. And that is, should be added to 1 minus 4. That's RBC. Okay? So simplifying, we have 3AX, we have plus AY because 3 minus 2 is 1. So we have 1 minus 4, we have negative 3AZ. That's the vector RBC. How about for the vector RBA? The terminal point is the final point is A. So we start with A. And then we have the initial points for B. So we have 2 minus negative 3 AX. And then we have negative 5 minus 2 AY plus we have what? 1 minus 4. So we have 1 minus 4 AZ. So we have 5 A sub X. Okay. And then we have negative 7 AY. Then we have negative 3 A sub C also. So now, we are now ready to get the cross product of RBC and then RBA. So, to get the cross product, what are we going to do is to simply put it into some sort of the matrix. So, we have AX, we have AY here, and we have AZ here. And we are going to put the coefficients for AX here in order, RBC and then RBA. Coefficients of AY here, and coefficients of AZ here. So we have 3 and 5. Of course, for RBC, we have 3 and RBA, we have 5. Then we have 1 and negative 7. We have negative 3 and then negative 3. So what are we going to do is, if we wish, the cross product results into a vector quantity. So to perform cross product, what we need to get is actually what? Okay, is actually, if we need to get AX, okay, what are we going to do is to completely block, okay, our eyes here, okay, and then perform the determinant, okay, of AY and AZ. Okay, so how do we do that? Okay, so we don't care about AX. Okay, we are blocking this column to get AX. Okay, and then we're going to get the determinant of this. So how do we do that? Again, applying sign convention. Okay? So we are going to apply sign convention here. So when we get AX, it should be positive. When we get AY, it should be negative. So we have plus, minus, and then plus. That's the rule. Okay? You should understand that. So we have plus, automatic, that's positive. Okay? So we have to block this column as if we are not seeing this AX, okay, in order to get AX. So get the determinant. So that must be 1 times negative 3. That is negative 3. Okay. That is negative 3. Let me just rewrite. So we have 1 times negative 3. 1 times negative 3. That is negative 3. So negative 3 here. Minus the other diagonal here. The sum of the product of the other diagonal here. Negative 7 times negative 3 would be 21. So this would be plus 21. And that is in terms of the AX. Okay. Okay. So this should be negative 21. Okay. So if we perform the determinant, I forgot to mention, okay, the sum of the products of 1 times negative 3, that's negative 3 minus, okay, the products of the other diagonal. In that case, that would be 21. Okay, negative 7 times negative 3, that would be 21. And then we have AX here. I hope you get what I'm trying to say. If we get the determinant of 2, 1, 3, 1, we know that that should be 2 times 1, 2 times 1, minus the product of the other diagonal. Okay, that should be 1 times 3. Okay? And that results to negative 1. So the same thing that we did here. So what we did here again first is to 1 times negative 3. That's negative 3 minus, this is that minus sign. Negative 7 times negative 3 is 21. Okay? And that we have for AX. And take note that the sign convention should be plus. Okay? And then minus, that is the essence of this minus here. Minus, okay, what are we going to do now is as if we are going to cover this A sub Y here. Okay? So we're going to cover that and get the determinant of this and this. Okay? So let me just control Z it. Okay? So as if we are not really seeing this AY, but we already include the sign here, which is the negative. So we have 3 times negative 3, that would be negative 9 minus, okay, the product of the other diagonal, which is 5 and negative 3. So in that case, that's negative 15. Okay? Negative 3 times 5 is negative 15. That's the AY. Okay? So how do we get the A sub A? So as if we are going to treat, okay, this A sub A as nothing. Okay? And then get the determinant of this 2. Okay? So, and of course, don't forget that the sign convention now should be plus. So we have plus here. So that should be plus here. Okay? Plus, okay, so we get this, the product of this. So we have negative 3 times negative 7, that is negative 21. And then 5 times 1 would be plus, okay, minus, okay, minus 5. That's the determinant. Minus 5. A sub C. Okay, that's the formula for the determinant. That's why we have minus, okay, for the other diagonal. Okay, so again, negative 3 minus 21 would be negative 24 AX. So we have minus negative 9, negative times negative here, negative times negative here would be positive. So this would be 15 minus 9. So that's 6, but we have a negative sign here, so this becomes negative 6. Okay, so we have negative 6 A sub Y. And then we have negative 21 minus 5. So that should become negative 26 A sub Z. Okay? So this is now the cross product of the two vectors. Okay? So take note of the sign conventions when we are doing the cross product. Okay? So that's how we do it. So for letter B, the cross product is also used to find the area of the triangle. So what are we going to do is the area of the triangle is actually 1/2 what? The magnitude of the cross product of RBC, okay, and then RBA. Okay, RBC and RBA. So that's the formula. So simply, we need to get the magnitude of the cross product of RBC and RBA and then divide it by 2. So if we do that, we have 1/2 multiplied by the magnitude of the cross product of RBC and RBA, which is this. So we have negative 24 squared plus negative 6 squared. Then we have plus negative 26 squared. Okay? So if we do that in our calculator, we get 17.94, okay, as our square units answers. Square units. So because we don't have any units here. Okay? So that must be our area. So the cross product is useful for getting the area. Okay, so for letter C, for our last problem, a unit vector perpendicular to the plane in which the triangle is located. So a unit vector, simply the unit vector of RAB and RAC. So how do we get the unit vector? So that's the unit vector. So we have RBC cross product of RBA, okay? Because that's the triangle already, and then we get the magnitude. Okay? So it seems like we are going to we know this already, the cross product of RBC and RBA. So that's negative 24AX minus 6AY minus 26A sub C all over the magnitude of RBC and RBA. Okay? So we know that already because we did it. So we have negative 24 squared plus negative 6 squared plus negative 26 squared. So if we get the result of the denominator, so that should be negative 24ax minus 6ay minus 26a sub c all over, we have 2 square root of 322. So to get the unit vector, again, our result should be a unit vector. It should be a vector. Okay? So we need first to get negative 24 divided by this value. And if we do that, so we get the value for our x component as negative 0.669 a sub x. Okay, and if we divide negative 6 with this number, we get, for ay, we get negative 0.167 ay in 3 decimals. And lastly, we divide negative 26 by 2 square root of 322. So that must be negative 0.724 a sub c. So that's the unit vector in which the triangle or in which the it is perpendicular to the triangle. Okay? So that's the unit vector. So I hope you learned something for this video about the dot product and cross product of vectors in electromagnetics. Again, this is Engineer Abat. See you again on the next electromagnetics video. Thank you and God bless.